Hello guys, welcome back to our channel. Today we are going to see what is an off subtractor and how to make the Verilog code for this off subtractor. So to make this off subtractor, we require one XOR gate, one AND gate and one NOT gate. By using these three gates, we can make the off subtractor. So for that, I am taking the one XOR gate and one AND gate. Here for one input of the AND gate, use the NOT gate. Here we know that there are two inputs for half adder. These inputs, the A will be connected to the one of the input through NOT gate and other will be directly connected. Here at the XOR, we will get the difference output of the two inputs, and here at the AND gate we will get the borrow of the two gates. That means here we can construct the truth table. A, B, these are the inputs. The possible inputs are 0, 0, 0, 1, 1, 0, 1, 1. That means here two inputs are there. So 2 power n inputs. For n inputs, we will get 2 power n outputs. That means 2 power 2 equal to 4. So these are the four possible combinations. Here we will get difference and we will get borrow. Here A and B. Here A and B, the inputs are 0 and 0. If we apply the 0, 0 to the XOR gate, the value of the output of the XOR is only high when the both of the inputs are different. Otherwise, the output will be logic low. So, here the both inputs are same. So, the difference will be 0, and here the borrow. One of the input is A, which will complement to the 1. So here 0. So 1 into 0, 0. So 0. Here 0, 1. The difference will be 1. And the borrow also will be 1. Here you can see that 0 and the 1. If you apply the 0 at A and B at the 1, 0 will become 1 at this place. And here 1. 1 into 1, 1. So the borrow will be 1. Here 1, 0. 1, 0. The XOR of the 1, 0 will be, the output is 1. And the borrow, here if you observe, here I am applying 1 and here applying 0. This 1 it become 0 at this place. So here 1 is, and here 1 will be there. Sorry, here 0. So here 1, here 0 into 1 will become 0. So the borrow will be 0. Here 1 into 1, the XOR of the 1 into 1 is 0 and the borrow will be 0. So this is the truth table for the off subtractor. So now we will make the Verilog code to design this off subtractor and we will verify the functionality. Okay guys, let's start making the Verilog code for the off subtractor. Now I am going to use the data flow modeling to design this off subtractor. So for that, primarily I have to design the module, create the module. I am going to create the module with the name called off subtractor. And for this off subtractor, we require two inputs, input A comma B, and the outputs are nothing but difference and borrow. Okay, I'm closing this module. Now I am assigning the operation to the A, difference and the borrow. For difference, it is nothing but the XOR operation. So for that I am applying the XOR between the A and the B, and for the borrow it is nothing but the AND gate, but we have to apply the NOT gate for the single input. So assign borrow equal to A into B. That's it. The module is finished. I am closing this module by using the command. And here is the design code for the off subtractor. Let design the test bench to verify this functionality. So for that I am going to design the test bench with the name called module tb, and again defining the inputs and the outputs. Here the inputs will be defined with the help of a register a comma b, and the Outputs will be defined using the wire. The outputs are nothing but the difference and the borrow, and will end this line by using the semicolon, and the module name subtractor, subtractor 1. Here I am writing all the inputs and the outputs: a comma b comma difference comma borrow. Okay, now I am starting the giving values to the each input with the command initial begin, and using the command dump file, which I will be used to get the and dump pads. These two inputs are used to get the graph file at the output. Yes, I'm going to give the outputs input different values to the inputs to whether verify the functionality of the op subtractor. So equal to 0, b equal to 0, and add 5, nothing but the delay, and same as, and just copying pasting 0 1 1, and finally 1 comma 1. These are the possible inputs we can give to the this module to verify the functionality, and finishing this test image by the command called finish, the semicolon, and finally end module. Okay, here is the test. Here is the design code, and here is the test bench code for the give of subtractor module. Let's verify whether this is working or not by clicking the save. Before that, we have to select the tools and the simulators. So for the IQ is Verilog 0.9.7, and selecting the Open EP view. I'm going to save this file and I'm going to run this. Yes, here we have to give some name. I'm giving the half subtractor. Okay, now am I going to save this file again? Yes, the file is saved and I am going to run this file again. Yes, the file is running. Yes, here there are two inputs are there. Yes, we have to give the half subtractor, nothing there, because the module name is called half subtractor. That's why we have to give the half subtractor. Okay, I'm going to say this. Yes, I'm going to run again. Hence, we got the output file for our code. Yes, here you can see that here a comma b both are the logic 0, so the bar and the difference obviously 0. Here a and b, here a is the 0 and the b is the 1, so obviously the bar and the difference will be 1 and the 1. This is same as nothing but the truth table of our of subtractor. And thank you for watching this video. Stay tuned for the next video. If you have any doubts, please mention in the comment section. Thank you.